Thank you for joining me for this talk on the impacts of climate change on plants, and specifically on flowering time in plants. I want to give you an overview of the dramatic effects that have happened over the last 30 years, basically, and to think about what the implications are of that for the natural world. My name's Alastair Fitter. I'm an emeritus professor of ecology at the University of York, and I've been interested in climate change as a biological phenomenon for a very long time. So I'm going to start by asking a simple question, which should be very straightforward to answer. When do fritillaries flower? These are some fritillaries at the bottom of my garden. It's an iconic species, probably not a native species in Britain, but nevertheless one of great conservation interest, and certainly aesthetically magnificent. And I've been keeping an eye on these for some years as to when they flower. And so I'm going to show you what I can gather from the obvious literature of floras and things of when fritillaries flower. And the answer is, if we take snake's head fritillary, that's the English name, the answer is that they flower, they used to flower, I should say, up until the middle of the 20th century in May and June. And all the floras were quite consistent about that. The only one that's a bit unclear is Bentham and Hooker, who merely say spring, but that's not very helpful. But spring probably in 1937 really did mean May, and certainly not April anyway. And then if we look at what the floras written in the second half of the 20th century say, the answer is quite different. They're all absolutely consistent. They say that fritillaries flower in April and May. There are a couple of minor exceptions to that, but these are local floras, which are referring to much more defined populations. So Gilham's flora of Wiltshire suggests late April, early May, and the flora of Oxfordshire suggests just April. But everybody agrees that after the middle of the 20th century, they flowered in April and May, not May and June. So it seems to have come forward a month in that period. Now you have to make some allowance for the fact it is true that not all flora writers go out and do their independent research, and there may be a certain amount of copying going on here, but even so, it seems to be quite clear that's what people thought they were doing. So the question then is, when are they flowering now? And I can show you when they flowered this year in my garden. They came into flower on the 11th of March, and they were all finished flowering by early April. So they had actually finished at the time when originally, only 20 years ago, they were held to start flowering. And that's pretty consistent. The last 4 or 5 years, they've always flowered in my garden, started to flower between the 10th and the 16th of March. So it's a very, very consistent behavior. And after all, I'm in York, which is reasonably far north, maybe not quite as far north as Newcastle, but nevertheless, not the south of England. And you might expect traditionally flowering time in a place like York would be a couple of weeks behind flowering time in the south of England. So probably if I went to Magdalen Meadow, I'd find they're coming into flower at the beginning of March. I don't know. I haven't been recently, so certainly wouldn't be able to at the moment. So it looks as though fritillaries are flowering much earlier than they used to. And that turns out to be a very general phenomenon and to be very easily explained. Because if you look at the temperature record for England, it matches it perfectly. So we're fortunate in England to have the best temperature record in the world. It's been reconstructed from various records going right back to the 17th century. So we have over 300 years of a really clear temperature record. And this graph shows the anomaly. So it's the difference in temperature between any given year and the average for the period 1961 to 1990. So unsurprisingly, in the period 1961 to 1990, out here somewhere, the deviations from that, the anomaly, is basically zero. If you look prior to that, it was nearly always, the red line is the running average of that lot of data. The average temperature was nearly always below, and if you look recently, the average temperature has always been above. So the temperature has warmed notably in the last 30 years. And that appears to be the obvious culprit for this dramatic change in flowering time of fritillary. Now, I got interest in this by looking at a very large data set that my father accumulated. But I want first just to talk about a much more widely available system, which is the program run by Woodland Trust called Nature's Calendar, which is a citizen science project. So anybody can just go out, see when they see something first flowering, and enter it on a database, a publicly available online database. And here we have, this, I haven't checked very recently, but when I last checked, the aggregated data were only available up to 2016. So here we have some changes in flowering time observed by people all across the country, all across the United Kingdom, in fact, what the first flowering date, FFD, stands for first flowering date, and that'll come up quite a few times in this talk, how it was in 2016 compared to 15 years earlier, 2001. And you'll see that here are three iconic spring flowers: hazel, western celandine, bluebell, and they all are flowering between 3 and 4 or even more than 4 weeks earlier over a period of merely 15 years. I mean, incredibly rapid change. And that, that makes a month in half a century seem like real slow coach stuff. Bear in mind particularly the one in the middle here, lesser celandine, which was flowering 27 days earlier in 2016 compared to 2001, because that will become relevant in a while. So as I said, I got interested in this because my father, Richard Fitter, who was a noted naturalist, recorded over a period of 47 years around in the general area around his home in Oxfordshire, the first flowering times of over 700 species of plant. And from that generated an extraordinary database of flowering times. And he analysed these together in the early part of this century, in just after the year 2000, because in the year 2000 he moved house and wasn't able to continue the record, so it seemed a good time to analyse it properly. So there he is, and this is a broad summary of the findings of his extraordinary record of flowering time data. So this graph shows the deviation of first flowering date in the period 91 to 2000 compared to the period 1954 to 1990. So if the numbers are up here are positive, then the plant is flowering later in the 1990s compared to the previous 40 years. And if it's down here, it's flowering earlier in the 1990s compared to the previous 40 years. And you can see that the vast majority of plants are flowering earlier. And the typical figure is around about a week. So flowering time seems to have advanced by about a week. Just in that decade, there was very little change in the period 54 to 90, but there was dramatic change in the period 91 to 00. And you can see that there are huge variations too. So some species barely change at all. Some actually are flowering later, which is a bit of a surprise, and most are flowering earlier. And there are some extreme examples of that. For example, the greatest advance was shown by white dead nettle, which in the 1990s, just in that one decade, was flowering 55 days earlier than in the previous half century, basically. And that seems to be because it had started flowering right through the winter. So it was possible to find plants in flower at almost any time, which simply wasn't possible before. So there were some really dramatic changes. There were also some very surprising delays. And remember Buglia Davidii, that'll come up again in a moment too. That was delayed by 36 days, which is a really surprising result. One doesn't really expect a warmer temperature to delay flowering, but it did. So that was a dramatic set of data. They were, at the time they were published in 2002, it was the largest data set which showed what the impact of climate change was on the natural world. It spiked a lot of interest. He and I were jointly interviewed on the PM programme, where he was asked why he had made all these records. And he just said, oh, when he was a young lad, somebody told him it was a good idea to make lists, and he'd never stopped doing it. So he hadn't done this in order to generate this sort of a result. He'd done it because it was interesting. And actually, I think there's a terrific important lesson there, that naturalists can, by just keeping their eyes open, contribute enormously to the advance of science, because nobody's going to do that. You wouldn't get a research grant to say, I want to spend 50 years recording flowering times. It just wouldn't happen. So if there aren't people willing to do it just because they're interested, our knowledge of these things will disappear rapidly, or will not be increased anyway. So here are some examples of plants that showed very much earlier flowering in the records that he made. So ivy-leaved toadflax was flowering 35 days earlier, greater stitchwort 25 days earlier. But now look at this one. Remember, in the Woodland Trust Citizen Science Project, lesser celandine was flowering 21 days earlier between 2001 and 2016. But it also, between 1991 and 2000, it was flowering another 20 days earlier compared to most of the second half of the 20th century. So that's 41 days. So in the space of 25 years, its average flowering time has come forward by 6 weeks, which is an astonishing change. I mean, these are not small alterations in biological behavior. These are radical changes in the way the natural world is operating. So that's a remarkable result. And it's fascinating that the two sets of data match so well. Now, my father's data were entirely on wild plants. He didn't record garden plants, though they had a wonderful garden, so I have no idea why he didn't, but anyway, he didn't. But a guy called Fred Lust, who was a professor at the University of Edinburgh, did that, and the advantage of a garden plant study, it doesn't tell you anything about the native flora, but the advantage of a garden study is that it's the same plants, or many of the same plants anyway, whereas if you are recording first flowering dates of wild plants, unless you go back to the same population every time, which he didn't, there is variation built in that, because one year you might find a particularly early flowering clump or something like that. So there's an advantage to the garden things. I think inspired by Fred's study, the Robert Hannett Garden Edinburgh also had a long-running phenology program where they did the same thing. They went back to the same plants, but I haven't analysed those data here. They are available in the RBGE publications. In Fred Lust's garden in East Lothian, Mahonia japonica advanced by 3 months between 78 and 2007. That's 3.5 days a year. And Daphne Mazerian advanced by 3.1 days a year. So there were some really dramatic changes taking place with garden plants over this same period, or a very similar period of time. So this includes the period from about 1990, when climate began to seriously warm up. And that raised the question to me, just sort of the general question, when do plants flower? Is there some sort of general pattern? Astonishingly, I could find no data, where there was no published data saying what the average flowering time for British plants was. So I went back to the floras. I used things like Clapentine and Warburg and any other flora which gave flowering times for the 20th century. I looked at all those floras and I worked out, it was just done by month, because that's what they say. They just say May or June or something like that. So I took the first flowering month and did an accumulation graph. So in this graph says that by the 1st of March in the British flora, the green line, about 5% of all British plants should be in flower according to the floras. and by the 1st of May, let us say, something like 15% should be in flower, and by the 1st of June, something like 40% should be in flower. That's according to the florers. And from that, you can deduce a very simple statistic, which is the date on which half the flora is in flower. And if you do that for the British flora, that's this green thing here, they hit 50% in about sort of the 10th of June, thereabouts. So in the second half of the 20th century, according to the florers, by the 10th of June, half of the British flora was in flower or had flowered. I then did the same for the data in my father's data set. So that's about 700 species in Oxfordshire. And that comes out with a very simple, that was recorded at the same time, second half of the 20th century. This comes out with a very, slightly earlier. In his data, it's about the 31st of May, but it's sort of 10 days earlier. And these are actual observations, so that if something often flowers at the end of May, the florers may well say June. So it's not perhaps surprising that the data that are actual observations come up with a slightly earlier 50% of flowering time date. So I then did the same. Because of my father's, I felt slightly ashamed that I'd never done this sort of recording. So I started recording my garden in about 2015, I think it was. I started really doing it properly. So I did the same for my garden. It turned out that I'd got 1,100 species of plants in my garden, which rather surprised me. So here we are in 2017 in my garden. And the 50% flowering time, the time by which half the plants in my garden were in flower, was actually before the end of May. It was about the 25th of May, which is a whole month, more than a month earlier. And this is for a place 200 miles north of Oxfordshire, where things one would have thought, be flowering later. So that suggested that there had been, and this is another way of showing there's been a general shift of flowering time. Everything is flowering about a month earlier. And then I had a horrible thought. My father's data are entirely wild plants, but my garden is largely garden plants. However, there were quite a lot of wild plants in my garden. There were 270 odd species, in fact, of wild plants in the garden. So I just did the analysis just for the native species. And it comes at exactly the same answer. So the 50% line it's marginally earlier, in fact. I'm not sure it's not a significant difference. So it's end of April. So in 2017, native species were flowering over a month earlier in York than they had been in the late 20th century in Oxfordshire. And that's a pretty startling across the board change in the way the natural world is behaving. So I think there is no question but that flowering times have altered, and have altered really quite dramatically in the last 20 or 30 years. And you can look at some interesting details of that. This is going back to my father's data again. So this is from the period 54 to 2000. And the pattern of this change is very different for different species. So here's an example of spurge laurel, Daphne laureola, which basically has just been getting progressively earlier. And that's it is true that the 1990s around here are particularly early, but there does seem to be a general trend to earlier. So, it may be that it is actually, later here and earlier there, but was not quite sure. But certainly, you now get Daphne laureola sometimes in flower actually at the end of December, not even there. So it had advanced by 27 days, but it seemed to be a fairly progressive change. And then there's one which has just only bothered to respond when the climate warmed. So here's an example of ivy-leaved toadflax, now flowering much earlier, but that effect is really very recent and dramatic. It now flowers really early. You can see it in flower in January these days. But it used to flower quite consistently in April. And then suddenly, as climate started to warm in the 1990s, bang, it started flowering earlier. So clearly, the evidence suggests that one is responding to temperature. Greater stitchwort's a particularly interesting one, and it says something curious about the Cymbellaria too, the toadflax, because greater stitchwort, yes, is earlier in the 1990s here, very clearly, but there are these years here with very early springs when it responded. So in 1957 and 1961 and 1975, when there were particularly warm and early springs, it responded, but ivy-leaved toadflax didn't. So clearly, different species are responding to different, they may all be responding in some way or other to temperature, they may not, but they may be. But if they are, they're responding to different, after all, temperature is a very complex variable in the environment. So it's not, perhaps not surprising that it should be different. And of course, then there are those plants that flower later. And this is a bit of a mystery because the buddleia was the one which both Fred last and my father came up with delays on, and there was an extraordinary one with a garden plant, Persicaria vaccinifolia, which was delayed dramatically, and it now flowers really late. It's actually still in flower in my garden now in late November, but it used to be a spring flowering thing, and it became a late summer and autumn flowering thing, which is really, really weird, and we don't have a proper explanation for that sort of behavior at all. So it's not just flowering earlier, it's flowering earlier. So the responses of plants to temperature are really complicated. So that leads to the question, well, what does determine flowering time then? Well, there are a number of things. So one thing is development. So plants may initiate flower buds at different times, and if they haven't initiated flower buds, they can't flower. So summer flowering bulbs, such as lilies, they don't form flower buds until that's just before they flower, when they start to grow in the spring. Whereas winter or spring flowering bulbs, like daffodils and snowdrops and things, they form their flower buds before they go into dormancy in the summer. So that's why you can take a snowdrop, and if you can break its dormancy and get it into growth, it will flower at almost any time of the year because they have the buds in there already. The same sort of phenomenon is with woody plants, some of which flower old wood, new wood. Every gardener knows that when you prune them matters. If you prune the wrong sort of plant in the autumn, you won't get any flowers next year. If it's something that flowers on the old wood, it won't flower next year because you've pruned off all the flower buds. Whereas if it flowers on new wood, you can prune it in the autumn and it will produce new flower buds in the spring. So development is one of the factors. Day length, perhaps the best known factor everybody knows about, long day plants and short day plants, though actually we shouldn't call them that. We should call them short night plants and long night plants, or actually even better, we should call them shortening night plants and lengthening night plants, because that's what they're responding to, that's what they're measuring. They have an incredibly clever hormonal system which detects infrared light, and they have a hormone which can change its state depending on when it's left on its own, it decays into another state, and it's kicked into one state by infrared light and then decays back. So it can measure the length of the night because there's a burst of infrared light at sunset. And we know that some plants will only flower in the nights are shortening. So it's a good example of red campion, and we know there are other plants which will only flower when the nights are lengthening, and that's a good example of that is hop. So that's called a short day plant because it requires short days, but it actually requires lengthening nights. Some plants we know are day neutral. They don't care. They will flower, whenever conditions are otherwise suitable. But bizarrely, even though this is one of the most famous pieces of plant physiology, as it were, we don't know for most plants. We just have to infer from when they flower whether they are long day or short day plants. So we don't actually have the data for most plants. So it's almost certainly incredibly important, but we don't actually know how important. But I mean, unsurprisingly, you would expect me to say that temperature can also be important. So here's data from a different data set, another really important set of phenology data, flowering another time data. This comes from a set of data collected by a family called the Marsham family in Norfolk over a period of several hundred years. And they used to send these data to the Royal Meteorological Society, who sadly decided they didn't want them anymore in the 1940s. And the family stopped collecting what had been the most remarkable data set. They didn't just collect flowering times, they collected things like frog spawn and other things like that too. And this is some analysis by a guy called Tim Sparks, in which he showed the relationship between the time of flowering. So this is Julian day. So the 1st of March is about day 60. So that's roughly the 1st of March around here. And therefore this is around the 1st of April, and the beginning of March is down here somewhere. This shows that if you measure when they flower in April, March, February, against the temperature in February taken from the Central England temperature record over a very long period of time, you find this incredibly good relationship. So the warmer the February, the earlier it flowers. In fact, this is flowering in mid-February here, when and typically in February generally, when the temperature in February is 5, 6, 7 degrees. That's the average temperature. It's a really mild February. When you have a ferociously cold February, it may flower way into the end of March. So it's quite clear that temperature has a huge impact on flowering time in this particular plant. And you can show that in lots of things. Incidentally, in December 2016, I had coltsfoot in flower in York, so that's way down off the bottom of the screen. So it's also advanced dramatically in recent times. Warm springs and warm autumns are interestingly different in their impact. So for spring flowering species, what we generally find across a wide range of data sets is that every degree centigrade increase in any given month up to 4 months before flowering advances the flowering date. And it's pretty typical by 3 to 4 days. That's across a wide range of species. There's variation in that, but that's a pretty typical figure. The really bizarre thing is that warm summers or autumns, that's 6 to 8 months before the first flowering date, delay flowering by almost as much, and we don't know why. It's really strange. When I raise this with plant physiologists, they'll say it's vernalization, but vernalization would be an odd explanation because this applies to annuals, herbaceous perennials and trees, and it's hard to see how vernalization has that sort of effect. So it's more complex than that. And here are some examples of species for which this is true. They are delayed in flowering. But despite all that, there is no question but that February is the most influential month. And one of the strange things is that about that, one of the reasons why there's been such a huge impact is that February has been particularly affected in recent years by temperature. So this is a graph of the anomaly, February in 2019 compared to the period 1981 to 2010. And you can see this is incredibly warm. This is anything bright in the red, dark red is 3.5 degrees warmer. Even up here in Scotland, the Cairngorms, crikey, Cape Wrath, all sorts of places. Very few places were less than about 2 degrees warmer. So February was incredibly warm, and unsurprisingly, everything flowered ridiculously early in February in 2019. And the effect of a February change is that very roughly averaged across all species, spring flowering advances by about 6 days per degree, a huge change. So this 3.5 degree thing is 3 weeks advance of flowering. So I started my talk by asking the question, when will it flower? And I've given you lots of information showing that flowering time has changed dramatically over the last 30 years. And so it's reasonable enough to ask for the answer to the question, when will it flower? And I have a very simple and straightforward answer to the question, which is I haven't a clue, because it's so variable across species, and the complex set of factors which determine flowering time are so poorly understood that we can't actually make clear predictions. We can say that things will start flowering, will go on flowering earlier if it goes on warming, but by how much earlier, we don't know. And there will also be delays. And again, we don't really understand those either. So making predictions at the species level is very difficult. Making predictions at a generic flora level is much easier. We can, I think, reasonably enough say that many spring flowering species will continue to flower earlier, and they will often start flowering right through the winter. I mean, these are some photographs taken in my garden on the 1st of January 2017. None of these plants should have been in flower. These are not winter flowering plants, they are spring flowering plants. Potentilla tabeli montani carries the vernacular name spring cinquefoil, and so it shouldn't be in flower on the 1st of January, but it was. Autumn flowering plants, on the other hand, may possibly show less change, because it's quite likely that many autumn flowering plants are triggered by day length, though we don't actually know that. We do know for things like Michaelmas daisies, they definitely are triggered by day length, but autumn crocuses, they do seem to me to be flowering much earlier than they were, but that's a casual observation. I can't really be sure. And we don't really know the triggers for other species. So another question you could ask, well, does it matter? I mean, flowering time, who cares in a sense if everything's flowering a bit earlier, so be it. Well, there are quite a few cases where it might well matter, actually. For example, a lot of species have specific pollinators. if those pollinators don't respond to flowering time in the same way, they may lose out. So fly orchid has a specific wasp pollinator. I don't know whether the wasp pollinators is responding to flowering to climate change in the same way, but if it's not, the fly orchid's in trouble. Another category is seed feeders. That might be quite good for the plant, might not be so good for the seed feeder. And we actually can look at that question with more of my father's data, which is, sorry, he also measured first emergence dates of butterflies. So we can actually plot the first emergent date of orange tip against the first flowering date of cuckoo flower, its main food plant. And we can see that fortunately they are responding, fortunately for the orange tip anyway, they seem to be responding similarly to changes. Another possible, which might have really big long-term impacts, is on the likelihood of hybridization. So if species flower closer together, they're more likely to hybridize, and if species flower further apart as a result of climate change, they're less likely to hybridize. And since hybridization is one of the main drivers of evolution in plants particularly, this could have long-term evolutionary consequences. So we could get wholly new species emerging because species which never had the opportunity to hybridize before now start to hybridize. And that could be quite important. We don't know, but it's perfectly reasonable to speculate on that. So what I hope I've told you is that flowering time has changed dramatically. We are pretty sure that climate is a major driver of this. Temperature clearly is hugely important in determining flowering time, particularly early spring temperature, which just happens to be when most of the climate change in Britain, at least, is most evident. I've suggested that flowering time changes could have important ecological consequences. What they really don't are as a harbinger. They're telling us about other things going on. So if plants flower earlier, they're also going to be growing earlier. And that will have huge impacts on things like competitive interactions, nutrient cycles, a whole range of other things that we don't really properly understand well. So ecosystems will be altered by this. Obviously, there are also going to be other impacts of climate change on plants, like range changes and so on. And these collectively, all taken together, are going to have profound impacts on disrupting ecological relationships. So we can reasonably expect that there will be changes to ecosystems over the coming years. But what those are and what those are going to be, and we can tell there will be changes, there will be extinctions, there will be colonizations, there will be new species emerging. But to make any detailed predictions about that is extremely difficult. What it also tells us is the value of naturalists doing work. And I think almost the most important lesson out of this is how valuable the work done by naturalists going out into the wider world and noting down what they see. Just seeing it actually is great fun, but it doesn't help anybody else. But if you can make records of it, whatever it is, whatever is your passion and enthusiasm, note it down and record it, and let the various data centers that record such data have your data. It is immensely valuable. Thank you very much.